Welcome back to a new episode in Scientific Smart Coaching. Today we shall discuss over ICSC Class 10 Physics, and the chapter should be a very important one: force, work, power and energy. The marks distribution suggested that this chapter carries marks of 20 to 24 marks, yeah, in the board exam. So we should read a lot, we should practice a lot numericals, uh, we should emphasize this chapter at utmost interest. So let's start this chapter, that is force, work, power and energy. Force, work, power, energy, and also simple machine. The total marks should be vary from 20 to 24 in the board exam. So let us discuss some theory in this chapter. So uh, we know about the moment of force or torque. Turning effect of force about is axis. It's a vector quantity, and the formula is torque equal to F into distance. SI unit of torque is 1 nm, that is 10 to the power 7 9 centimeter. 1 kg/Fm equal to 9.8 nm. Equilibrium is the state of body. Book lying on the table is equilibrium state. Revolution of the earth around sun is an equilibrium state. Principle of moment: along sum of clockwise momentum equal to algebraic sum of anticlockwise moment. Example: beam balance. Center of gravity: point on a rigid body at which entire weight is assumed. Work: work said to be done when there is displacement in direction of force. Work done by force of gravity, W equal to mg. Work done against the force of gravity, W equal to minus mg. Work done, example of work done by force of gravity: apple falling from a tree. Example of work done against the force of gravity: ball through vertically upward, that is W equal to minus mgh. Power: it is the rate of doing work per unit time. It's a scalar quantity. Unit of power is 1 watt, that is joule second, 10 to the power 7 arc per second. P equal to W by T. P equal to F into velocity. Energy is the capacity of doing work. It is also scalar quantity. When work done by energy is when a striker hits a corner coin, E equal to W here. 1 horsepower equal to 746 watt. 1 kilo WH equal to 3.6 into 10 to the power 7 joule. Potential energy possessed by virtue of position of configuration, that is water stored in tank. Kinetic energy possessed by virtue of motion, K equal to half mv square. Gravitational potential energy due to gravity, U equal to mgh or U equal to mg h2 minus h1. Work done, work energy in equal to kinetic energy. Law of conservation of energy: total work done equal to constant. So these are some theoretical questions. Let us discuss some theoretical questions. So what is a machine? In simple machine, let us discuss some questions. What is a machine? So machine is a device. Actually, it is a device where we can overcome a resistance. To overcome a resistance by simply applying some force. Applying a comparatively small force. By applying a comparatively small force, and then we can overcome in a larger distance. Principle of machine, that is the input work done on a machine, the work done on the machine or input work. In an ideal machine, the output work of a machine is equal to the input work. So principle of machine. Input work equal to output work. It is for the output work is equal to, give an example where machine is used to obtain gain speed. A machine to speed, that is to obtain speed. Example, gear arrangement, where there is a gear arrangement. Gear arrangement in the cycle also there is a gear arrangement. So here a machine is after, here a machine is applied to obtain a speed. Efficiency of an ideal machine. Efficiency of ideal machine. Ideal machine. It is 100%. 100%. Actually, efficiency, expression of efficiency. Efficiency E equal to mechanical advantage by velocity ratio. Mechanical advantage by velocity ratio into 100%. So it is the mechanical advantage of velocity ratio into 100%. So these are some important short questions. Let us do some other short question also. So how does a machine work? How does it work? How does it work? Machine actually works. Machine does some useful work when energy is supplied to it. So effort, here effort into displacement. Here energy supplied to the machine input equal to effort into displacement. This effort into displacement equal to energy supplied. Energy supplied to the machine. So energy supplied to then this is effort into displacement, and work obtained equal to load into displacement, and work obtained equal to load into displacement. And in ideal machine we said we shall discuss it, that is the output work equal to input work. This is for the ideal machine. Give an example of the following to change point of application. So there are different types of machine. Change point of application. Application change. Where point of application change in a paddle. Point of application changes there. Rotation of wheel of cycle by applying a paddle in cycle. Next, to obtain gain in force. Gear system, or lifting a car by jack, lifting car. You have observed that in the washing of car there is a lifting of jack there. So this is to change the direction of force. Change direction of force. Change the direction of force in well, that is to lift water. So these are some examples. Why is machine useful? Usefulness of machine. How is machine useful? Usefulness. So these are the different points where we can say that machine is useful, because the point of application change in the paddle. In this way, it is a change of direction. And gain in the force. So these are some example. Machine can be obtained to gain speed used to lift load in one direction by applying. So these are the different. What are the efficiency of machine? Efficiency of machine. So efficiency of machine. This is actually a ratio. Efficiency of a machine is a ratio. Ratio. Ratio of which one? Ratio of work output by work input. Work output. Output by work input. Work input. And the relation between mechanical advantage. Relation between mechanical advantage, efficiency of machine, mechanical advantage, VR, efficiency and VR. What is the relation? Let a machine be overcome. Let a machine be overcome a load. So load if L, applying on effort is E. Then its work input. Therefore, work input equal to effort into displacement. Effort into displacement equal to E into dE, and work output equal to load into displacement into displacement of load equal to L into dL. Now according to principle or by the efficiency, so efficiency equal to work output by work input. We know that input equal to work output is how much? L into dL, and work input is L into dE. Now this one should be cancelled. Oh sorry, E into work input is E, not L. Here we have written the wrong one. E into this one is effort, so this one is L into dL. So this one, so we can say L by D equal to L by E, and this one is E by DE by L, DE by DL. But we know that L by E equal to MA. Therefore DE by DL equal to VR. DE by DL equal to VR. DE by DL. Now efficiency. Therefore efficiency equal to work output by work input equal to MA by VR. Or we can say MA equal to VR into efficiency. What is the relation between mechanical advantage and the number of stand string used to support the load in block and tackle setup? Actually, the mechanical advantage block and tackle setup. In block and tackle setup. So it can be assumed to be ideal. That is, the mechanical advantage is equal to the number of strands in the string used to support the load only if the block and tackle setup can be assumed to be ideal. That is absence of friction. And the lower blocks or pulley have negligible weight. Both these conditions cannot be satisfied in actual process. Hence, in practical situation, The mechanical advantage of block and tackle setup is always less than the number of strands of string. So less than the number of number of strands of string string. Shears used for cutting metal and scissors used for cutting cloths are both example of lever of first order. So shears versus scissors is scissors. They are both lever of first order. Both lever of first order. However, the shears always have short blades and long handles, whereas the scissors often have blades much longer than the handles. Scissors scissors have blade is longer. Here handle is longer. Why? Because they for the shears using for cutting metals, it is used for cutting metals, and it is used for cutting cloths. Here handle is greater in a huge large amount. Here blade is large. Why? For shears, load is really formidable one. Therefore, we need to large mechanical advantage to keep the applied effort within reasonable. Here load greater as load. Here is, we should cut a metal, so load is greater. Load greater. Therefore, mechanical advantage must be greater. So handle is. Whereas have short blades. Here short blade and long handles. Short blade, that is small load arm. Handle greater than load arm greater than. Blade short less than effort. Handle is greater. So handle greater. Here is handle is greater. So we have blade, small short blade, small load arm. Short blade, here handle is greater, so load arm is so blade is short, so load arm is short. Handle is greater as load is greater. So you have to overcome that one. Now the following are example of lever. State which kind of lever this one. So scissor we know that it is first order lever. Sugar tongs third order. Sugar tongues is third order lever. Nutcracker second order lever. Pliers first order lever. What is block and tackle system? We have just discussed. Block and tackle system. What precautions should be observed while setting its string so that the effort is applied in a downward direction? While setting the string, it is ended is attached to the hook of movable block if the number of pulleys is fixed block. So these are some questions. So we should do numericals in the second part of this program.